In today's video, we'll be talking about how you can get objects charged. After watching this video, you should be able to understand the law of conservation of charge, be able to describe how an object can get charged by friction, by induction, and by conduction. So 3 different ways you can learn how to charge an object, and we're going to talk about all 3 ways today. What a great day it is. All right, let's get right to it. The first thing I'd like to talk about is the law of conservation of charge. Basically, charge is not created from nothing. So it's not like there's a charge-making factory that's doling out electrons or protons to give away to objects to make them charged. Instead, if an object becomes negatively charged, basically it gained that charge by taking electrons from a different object. Okay, so electrons lost by that object and are gained by the other object are its electrons. Okay, so basically, charging objects is basically as a transfer of electrons from one object to another. So whoever loses electrons is going to have an overall positive charge, and whoever gains electrons is going to have an overall negative charge. Electrons are the only thing that are transferred, okay, and that's kind of important. The protons, remember, they're big and lazy and they don't like to do much. So they don't do any moving, the electrons do the moving. Something to keep in mind is the net charge of the entire system will always be 0. And again, that just follows the law of conservation of charge. Charge is not created nor destroyed, it's just basically transferred. Okay, so if say this pen in my hand gives me 2 of its electrons, now I'm negatively charged. The pen has lost 2 electrons, but I've gained 2 electrons. The overall net charge of me and the pen would be 0. Okay, so that's the law of conservation of charge. Now, before we talk about charging, I just wanted to quickly discuss this idea called grounding. And you probably have heard of it before. But basically, grounding is the process of removing excess charge on an object by basically having a way for the electrons to transfer between it and another object of substantial size. Okay, so if I become charged, there should be a way that I could ground myself and basically release that charge into another large object. And typically, we use the Earth, because the Earth is so huge and so massive, it can really take a lot of electrons with relative ease. So a lot of times when your house is wired, or if you have like a lightning rod, those wirings, or the lightning rod, is let into the ground, and basically what ends up happening is any excess electricity just gets transferred into the ground, and no harm, no foul. The Earth is much larger than, say, any one lightning bolt or any like overload of electricity that may come out of a power plant. Okay, so that's what grounding is. Now, for grounding to work, a conducting pathway between the ground and the object has to exist. Okay, so if that lightning rod stops like 10 feet before it can actually go into the ground, it's just you have a lightning rod on your roof and it doesn't connect to the ground, well, that's not going to quite work. You need a path for those electrons to travel from the rod all the way down to the ground. Okay, so you must have a pathway for the electrons to travel. Okay, so that's just a little background information on grounding, because I'll refer to that as we're charging objects today. There's something called the Triboelectric Series, and basically the Triboelectric Series is just a series that was discovered a long time ago that looked at various items and their love for electrons. Okay, and basically folks up on the top here, these guys love electrons. Okay, they will happily take them. Okay, they're real good at taking them. People down here, they will give electrons very easily. Okay, so at the top they want to take them, and at the bottom they want to give them. So in a lot of labs, and my class included, we will charge a lot of things with rabbit fur, because rabbit fur readily gives away electrons to different objects. So if you want to charge a balloon, you take some rabbit fur and rub the rabbit fur on the balloon. Electrons from the fur go to the balloon relatively easy, because the balloon is made out of rubber, and a rabbit fur is, well, rabbit fur. And basically rubber loves electrons, rabbit fur is happily willing to give electrons away. And that's called the Triboelectric Series. Okay, I would never ask you like to memorize this, but you should just have an idea that various items have either a strong love for electrons or they're willing to give electrons away. So the first way you can charge an object is charging by friction, okay? And the name kind of gives it all away. Charging by friction is a transfer of electrons between two objects that are rubbed together, okay? And so an example of charging by friction would be rubbing some animal fur on a balloon, okay? That would be an example of charging by friction. Or if any of you guys have ever taken a balloon, rubbed it in your hair, and then stuck it on the wall, that would be charging by friction. Rubber has a much greater attraction for electrons than animal fur, and so the atoms of rubber pull electrons off of the animal fur, and then basically what ends up happening is the rubber balloon is negatively charged, it has an excess amount of electrons, and the animal fur is positively charged because it's lost electrons. The second way you can charge an object is charging by induction. And induction is basically a method used to charge an object without actually touching the object. And so this involves polarization, which was something that was discussed in the previous lesson. So here we have two metal spheres, and they are mounted on insulating stands. Okay, so these guys are metal, all right, both of them, and they're touching each other. Okay, now let's say I bring a balloon that has a negative charge near the sphere, but not touching it. Notice there's space here. What ends up happening is the electrons on this metal sphere run away, right? They immediately head as far away as possible from that balloon. Okay, so what is the overall charge of this sphere right now? Well, right now it has an overall positive charge, and this sphere has an overall negative charge. But the two spheres together, the net charge would be 0. Okay, if I then take my other hand and pull these two spheres apart, this sphere over here is now positive, and this sphere over here is negative. And that is what charging by induction involves. Basically, you require the electrons to move away from an object, and then when you separate the object from the thing charging it, you have charged spheres or whatever the case may be. So this is charging by induction. Another way you can charge by induction is, let's say you don't want the spheres touching one another. What you can do is, here you have a metal sphere, and it's neutral right now, and it's mounted on a stand. Let's say you bring a negatively charged balloon near the sphere. All right, same thing that happened in the previous slide happens again. The electrons run away. They get as far away as possible from this negative balloon, because remember, electrons don't like other electrons. If you take your hand and you touch the sphere, so you ground the sphere, the electrons are going to run out of the sphere into your hand and then into the ground. Okay, so what is the overall charge of the sphere right now? Well, it's positive, right? Well, if I take my hand away and then take the balloon away, I'm left with this, a positively charged sphere. And that would be an example of charging by induction also, okay, with just one sphere. The third way and final way is something called charging by conduction. And charging by conduction does involve contact, okay? So you can also call this charging by contact if you prefer. It's not a big deal to me. So how does that work? Well, let's take a look at this picture. Let's say I bring a metal sphere that has an overall negative charge next to this thing called an electroscope. And we'll take a look at these in class. If I have this negatively charged metal sphere touch the electroscope, the electrons in the electroscope immediately enter into it and spread out. Okay, and this is all made out of metal, so it is a conductor, and the electrons happily spread out. And what ends up happening then is the electrons transfer to this electroscope. If I take the sphere away, now the overall charge of the electroscope would be negative because it gained an excess amount of electrons. And that would be an example of conduction. Now notice there was no rubbing here, and that's why it's not called charging by friction. Instead, it's just, you just touch it, and now you've charged it by conduction. Okay, so just touching it. Okay, that takes care of today's video. I will see you guys next time.